So I'm going to go through and explain number 5 from the 2010 FRQ. So it gives you all of this information. Okay? And it says, draw the complete Lewis electron dot diagram for ethene in the appropriate cell in the table above. So you've got C2H2. So I know I'm going to have a total of 10 valence electrons. And so when you start to draw this out, just for you guys to know, the mistakes that I often see are people don't count the correct number of hydrogens, or they don't follow an octet rule, but there should be a triple bond, so you can see that there. So you get 1 point for that. And B, it says which of the 4 molecules contains the shortest carbon-to-carbon bond. So you get 1 point if you tell them ethene, and the reason why ethene has the shortest carbon-to-carbon bond, if you look at it, it has a triple bond, while all the other ones are single bonds, or yep, that's it, and only single bond. So remember, a triple bond is going to be stronger than a single or a double bond, and it is going to be shorter. So you get a point for explaining that. In CI, it asks for the geometry, and when someone had asked me, when they ask geometry, do they mean electron domain geometry, or do they mean just the molecular geometry? In general, they mean just the molecular geometry, but as you'll notice, if you put the electron domain geometry, you would have gotten II correct as well. So for carbon X, notice it only has 3 domains around it. It has 3 bonding domains, no non-bonding domains. Remember, because a double bond counts as 1 domain, therefore it's going to be trigonal planar. And for CY, it should be just trigonal. I would have just said that it's going to be tetrahedral. Now, the reason why they accepted trigonal pyramidal was because technically, so you've got the hydrogens coming off of that central carbon. And so if you imagine just looking at that carbon with those 3 hydrogens, then you might have said it was trigonal pyramidal, but I thought it should be tetrahedral. That's the answer that I would have put. Okay. And they put another option as distorted tetrahedral simply because the bond angle is going to be slightly distorted due to electron repulsions. So you get a point for putting the correct answer there. In D, it says energy is required to boil ethanol. Consider the statement as ethanol boils, energy goes into breaking carbon-carbon bonds, carbon-hydrogen bonds, etc. Is the statement true or false? Well, this is going to be false because remember, when you boil or you melt, you're breaking intermolecular attractions, not intramolecular attractions, which are represented by the carbon-carbon bonds, those covalent bonds. So make sure that you are talking, that you note that it's inter that we're breaking, not intra, so you get 1 point for that. Identify a compound from the table above that is nonpolar. So you could have either put ethane or ethene. So let's look at these options to make sure we understand. So ethane or ethene, if you look at those, the reason why those two are nonpolar is because their dipoles cancel. So make sure that you note that their dipoles cancel, and you get the point. They also accepted it if you said it was symmetric, but we haven't talked about that. If you talk about the fact that there are no lone pairs or that the carbon's just surrounded by hydrogens, you did not get credit for that. Okay, so you have 1 point for that question. And finally, for F, it says ethanol is completely soluble in water, whereas ethanol has limited solubility in water. Account for that difference in solubilities between the 2 compounds in terms of intermolecular forces. So ethanol has hydrogen bonding, while ethanethiol, I'll pronounce it that way, has only dipole-dipole attraction. So ethanol can form, and here's where people get points deducted. If you just say it has hydrogen bonding and you leave it at that, you will not get a point. What you have to say is ethanol can form hydrogen bonds with water, while ethanethiol cannot. Okay. So there it says the formation of hydrogen bonds increases the attraction between molecules of ethanol and water. So specifically noting that the ethanol will form hydrogen bonds with water. Okay, so you get 1 point for that. Make sure to always talk about the intermolecular forces, but then if it's asking about dissolving, make sure that you're talking about how the solute is being attracted to the solvent. So talking about the intermolecular attraction between the solute and the solvent. So in this case, it would be hydrogen bonding. Other times, for example, if you have a solid dissolving in water, let's say it's an ionic compound, then it would be an ion dipole attraction, right? Because the ions from the ionic compound and then the dipole created by water. So that would be another way that you could describe it if we were talking about a solid, an ionic solid dissolving in water.